Alright, welcome to the first video of topic 3, molecules. 3.1 is molecule polarity. Let's look at the content. Now in this video, we'll be looking at the first box there. So the shapes of molecules can be explained and predicted using three-dimensional representation of electrons as charged clouds and using valence shell electron pair repulsion theory. VSEPR theory it's called. And what you need to be able to do after this video is to be able to draw and annotate diagrams showing covalent bonds, non-bonding pairs, and also annotate the shapes of molecule or determine what the shape is, and ions, molecules and ions in which there is only one central atom and up to 8 valence electrons. Okay. Alright, so terminology, that's something that I wanted you to think about, is a molecule. Now we'll be looking at molecules only. We won't be looking at anything that's bigger than molecules. Hope you remember that they're usually small. It can go up to like say chromosome, something big, but that's still a molecule. Usually small. We are not looking at any polymer as well. Okay. 2 or more atoms chemically bonded, that as long as you have that, that's already a molecule. Okay. As I said, ionic compounds are not counted and a molecule usually have covalent bonds only. So think of non-metals. Right. We'll look at the video, a TED video that says how polarity makes water behave strangely. It's a small molecule but can stay as liquid, as in they don't fly off from each other. So we'll look at the video later. Now, shapes of molecules can be determined with VSEPR theory, VSEPR. So that is a valence shell electron pair, electron pair repulsion theory. Valence shell electrons. So valence shell is the first thing. So you need to be just thinking about the outermost shell and electron pair. So pair of electrons can become lone pair of electron, which is non-bonding, or bonding electron pairs. So all the pairs matter, but not the single ones. That's the theory. We will look at the video and we'll go through that together again. Pairs of valence electrons in molecules repel each other to position as far as possible, just like these puppies that you see in the meme there. So they want to be as far as possible. Imagine that they're electron pairs or bonds. They are sort of equally, dispersed around the bowl when they want to eat. So that's what we will be talking about. Very similar sort of concept. Okay. Repulsion occurs between bonding pairs of electrons as well as bonding and non-bonding pair of electrons or lone pair of electrons, and also non-bonding pairs and another non-bonding pairs. So as long as you have pair of electrons or double bond, triple bonds, they will repel each other. Electrons don't like each other, but they have to make bonds, so the bonds have no choice. Alright, using the VSEPR theory, what you can do is that you can predict and explain the shape of a molecule. So you need to identify the central atom for a molecule and draw the corresponding Lewis dot structure. Now, I hope you can do how you can draw Lewis dot structure for molecules. And the number of bonding and non-bonding pairs of valence electrons around the central atom. So we are still sticking to the Lewis dot structure. Convert the electron pairs are shown between atoms into line, so bonds, and redraw any non-bonding electrons. So they can stay as dots, but any bonds can be converted into single, double, or triple lines. Finally, I think, the spatial positioning of these valence electrons as a result of repulsion. Now, water, carbon dioxide, ammonia, we can look at that. As well as summary of the molecular structure shapes on page 99. When you look at that, you can find one answer for most of them. And we'll also look at how to determine the shape of molecule from its molecular formula, i.e. SO2 and SO3. They would have more than 8 electrons around the sulfur. That's what you would notice. But we'll also, I'll be explaining that anyway. Question 1 to 3 is what you're gonna do. As part of this homework, have a go. I'm gonna go back a bit. Have a go at drawing water, carbon dioxide, and ammonia. And by drawing the molecules, predict and explain shape of the molecule. What sort of shape would they have? Shapes would be something like straight. We call it linear. It might be bent like that. We will call that as V shape. And well, there are a lot more things, but we'll look at the shapes anyway. Just try drawing these 3 molecules. On a book there, and let's see if you can draw the use the VSEPR theory. All right, that's it. I will see you in the next video.